So we're going to go ahead and go over multiplying fractions. Again, we will do just a regular fraction multiplication problem, and then I'll do one with mixed numbers. So the first problem we're going to do is going to be 2/9 times 1/4. These ones I tend to write horizontally because we will just multiply horizontally. So the best thing about multiplying fractions is you do not have to have a common denominator. In fact, you don't need one at all. Don't do it. All we're going to do is multiply straight across. I'll show you a little bit of a simplifying trick in a second, but for the basic, if you get confused, anything like that, we just multiply straight across. So 2 times 1 is 2. 9 times 4 is 36. So I get 2 over 36, which can be simplified because I can divide both those numbers by 2. 2 divided by 2 is 1. 36 divided by 2 is 18. So my final answer would be 1/18. So the simplifying trick is that I can cross cancel, which just means that I don't have to do this step later. So the way that would work, and I'll do it in red, same problem, 2/9 times 1/4. I'm going to look diagonally in my problem, and if I can simplify diagonally, I'm going to go ahead and do that now. So if I look at 9 and 1, those are both, they can't be simplified by the same thing. So because 9 divided by 1 is just going to be 1. So that doesn't help me. But 2 and 4, I can actually simplify 4 by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So I've just simplified there instead of having to simplify my answer. Again, if this confuses you, just do it the regular way. 1 times 1 now is 1. 9 times 2 is 18. I get the same answer. I just simplified ahead of time. So I just looked across and said, can I divide those numbers by the same thing and get a smaller number? All right. For a mixed number, let's go ahead and do 3 4/5 times 2 1/2. So again, I don't have to do common denominators, but what I do have to do with a mixed number is I have to turn it into an improper fraction. Okay, so to turn it to an improper fraction, just as a refresher, I'm going to multiply my denominator by my numerator, so I'm going to multiply those, and then I'm going to add my multiply my denominator by my whole number, then I'm going to add my numerator in. I'll keep my denominator the same at the end. So 5 times 3 is 15 plus 4, so 15 plus 4 is 19. My denominator is going to stay 5. So 3 4/5 becomes 19/5 times 2 times 2 is 4 plus 1 is 5 halves. So now that I have both of them as improper, I can go ahead and multiply across. 19 times 5 is 95. 5 times 2 is 10. Okay, so I've got my answer to my multiplication problem, but now I have to simplify it back, which means I have to turn it back into a mixed number. So I can do a couple things. I can do the subtraction and pull out all my holes, but since it'd be 10/10 is one hole, that's a lot to pull out. So I'm going to go ahead and divide. 10 goes into 95. 10 goes into 90, I should say. 9 times 10 is 90. I have 5 as a remainder, so that's going to become my numerator. 10 is going to be my denominator. 9 5/10 is my answer, but that can still be simplified, and everything can be divided by 5, so that can be simplified to 9 1/2. So the answer to this multiplication problem is 9 1/2. We're going to flip to the back and do some dividing fraction problems. Again, I'll do just a basic one, and then we'll do a mixed number. So dividing fractions. The best thing about dividing fractions is we're going to make them multiplication problems because it makes it easier. So 5/6 divided by 1/2. Okay, so our rule with dividing fraction is that we are going to do KCF, which is to keep the first number, change the sign, and flip the second fraction to its reciprocal. And reciprocal means that it flips, so the denominator becomes the numerator, numerator becomes the denominator. So when I rewrite this, it's going to be to keep this first fraction the same. I'm going to change the division to multiplication, and then 1/2 is going to be 2 over 1. So I just flip my fraction. You only change division problems into multiplication problems. Don't go changing a multiplication problem into a division problem. That defeats the point. So we're just changing division into multiplication. Now that it's a multiplication problem, I'm going to multiply straight across. 5 times 2 is 10. 6 times 1 is 6. I have 10/6. This is a great case for just doing the subtraction. So I'm going to take 10/6. I'm going to subtract 6/6, which is 1. And I would be left with 4/6. So my answer so far would be 1 4/6. That can simplify, divide both by 2, to 1 2/3. So 5/6 divided by 1/2 is going to be 1 2/3. to do my mixed number, again, remember this is just review, so this is all stuff we've learned before. To do my mixed number, I've got 9 1/3 divided by 2 1/3. Again, same rule as multiplication. You can't do anything until it's an improper fraction. So I'm going to make it improper. I'm not going to flip, so I'm not going to do my keep, change, flip until it's a multiplication problem. Or, I'm sorry, until it's an improper fraction. 3 times 9 is 27, plus 1 is 28, so I've got 28 thirds divided by 2 times 3 is 6, plus 1 is 7, divided by 7 thirds. Right? Now I will keep 28 over 3, change, and then flip. So here is where that cross canceling can come in a lot of handy. Again, if you want to just go ahead and multiply 28 times 3, 3 times 7, multiply across and do that, that's totally fine. But based on my numbers I have here, this is a great way that I could use that. I'm going to look at my 3's first. I can divide them both by 3. So 3 divided by 3 is 1, 3 divided by 3 is 1. So I've canceled those and made that simpler. 28 and 7 can both be divided by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. So now when I multiply across, I have 4 times 1, which is 4. 1 times 1, which is 1. 4 over 1, or anything over 1, is just itself. So my answer would be 4. Okay. If that confuses you, just multiply across 28 times 3, and then 3 times 7, and when you actually do your simplifying, you will get 4 still as your answer.